Hello everyone, let's continue our dungeon crawler game, and today I want to visualize all the work we did on rotation and positioning in the last couple of episodes. So we already have a system there where you can move the player around and the player can also turn. Now let's use that in the game, and to do that we need to look into our world update system. So we already have there something that can interact with the world, or at least inspect the world for changes, and our content view already injects the world into the game view. So taking the world is a good first step to add at least a player. So this creates a default player in the default starting position and the default heading. And now we could set up some buttons. So we'll create a V stack that has a button called forward. And this will do world.player.move forward. And we can also create a couple of buttons that describe going left, one that describes going back, and one that describes going right. And again, this is movement, not turning. So the left and right here are not turning, these are strafing left and right. So let's see what this looks like. So we now have these buttons in the middle of the screen in a sort of inverse T formation. You can click the buttons, but you can't see the effect yet, and that's because we are not updating yet the player's position. So we could do that by setting the camera anchor to the world player position. But unfortunately the types don't match. So this is a coordinate in 2D space, and this is a 3D coordinate as a float. So we need to convert between the two, and I think the easiest way is to create an extension that says to simd3. And this will be simd3 float. This can just be an X, Y, and a Z. So let's see. So the X coordinate will be our own position as a float. So I think that should be float. The Y position is the height, that's 0. And the Z position is the Y coordinate. And so this doesn't completely match the coordinate system here that has an X and a Y that define movement on a horizontal plane. Whereas here we have a 3D space where the Z and Y coordinates are more or less switched. So we can now call our toSimD function. Let's see what this does. So we can go forward, although we're going backwards. Going backwards, that's moving forward. However, going left and right is working fine. It doesn't work as expected because the axes are inverted in RealityKit. So moving forward is sort of moving backwards around the z-axis. To make it even easier to visualize, what we can do is we are creating cubes somewhere, I think. They're always blue now. What we can do is we can create a color. And we can do a random value between 1 and 0. The rest can all be 1s, so it's fully saturated, fully bright, and fully opaque. And this should now show all the cubes in different colors. So now we can quickly see that if we move right, we're indeed moving into the against the pink one instead of the green one we have when we go to the left. So that's movement. Let's do rotation. So of course we can go back to our content view. We can wrap this forward button into an H tag as well, and add some buttons for turn counterclockwise, and something similar for clockwise. And now we have also a row of turning functions. So although you don't see the difference yet, you will notice that I click turn counterclockwise once. If I now go forward, I should see the yellow thing. And further, because indeed my heading changed, however, and thus my forwards and backwards as well. However, you can't see it on the screen yet because we're not changing our camera. So this requires also to change the rotation. So we can take our camera anchor transform.rotation, and we can create a new rotation. That's a SimD quaternion. And we can use the angle axis option. The axis will be our up axis. And then we rotate it around some angle. And what angle do we need? Well, we have our world.player.heading. But this one is in a compass direction instead of an angle. So we need something to convert those as well. So we could say we convert to angle around y-axis. This will be a float, and this requires some thinking. So north 0 is fine, pi 0 is fine as well. East is actually, I think it's actually turned around because of the way rotations work. I think rotations are by default counterclockwise, but we'll see what happens. So now we can do this heading dot to angle around y-axis, and let's see if this works more or less as expected. So I can still go forward. Let's turn clockwise. Let's see if we can walk around the purple and now the green wall. We could go back into our corridor. We can also turn and move around. We can also go the other way around. Well, this does seem to be working almost out of bounds, so we don't have a defined floor here anymore, although you could go as far as you want. But that's something to solve at a later time. So we have although we have walls in a visual sense, we don't have any concept of them in terms of gameplay. So we are moving through them, and you also see the one in front because you look at if we have here the green one and here the bluish green one. If we step into the green one, we only see the blue one because when you look at the cube from the inside, the faces are invisible. You could actually make them visible as well, I think. So they are rendered at both sides, but that's not something that we need at this time. Especially as we will make walls, not something that you can go through at this time. But at least this visualizes the moving around, and actually moving around feels kind of good. So I'm pretty happy with this result. I think we should also be able to add, let's see, key bindings, so a keyboard shortcut. See if I can do a up key here, up arrow, okay, cool. Oh wait, this is a rotation. So let's see, the rotations, let's start with forward and backwards. So forward could be the W key. And then this can be, we can do WASD. So this would be A. This would be S. This would be D. And then we could use Q and E to rotate, I guess. Something like this. Let's see if this this works. It doesn't. Oh, it doesn't. Oh, it works if I hold on the command key. So it seems that this works. This assumes that your shortcut always has a modifier key. So maybe, oh, I need to add that modifiers. Can I say none? Let's see if this works for the W. Okay, so this works. And the Q as well, because then we can use this trick here as well, I guess. And here, here, and here. Let's see what happens. So I can move forward, I can rotate. This actually feels much better than the mouse controls, because it feels much more direct. But this not bad. I think we should leave it at this and continue this next time, and then we can have a look at our backlog. So okay, we have this one done. Well, we could think about not moving through walls. That sounds like a nice next step, because it means we can start thinking about the actual maps. So what did we do today? Implement, let's say visualize movement and rotation in the RealityKit view. We have also keyboard shortcuts. Crazy way to control the player. Update a view as player moves and rotates. We have keyboard shortcuts, and we have extra colors for the walls, so movement is more explicit. I should say depth is more explicit. Okay. Anything with tech depth? I don't think at this time. Let's commit this. Okay, thanks for watching and have a good day.